Hi, I'm Lauren Brown, and this is my two-dimensional projectile motion video test. So for my test, I decided to incorporate my passion of tap dancing to show projectile motion, so I decided to do a front pullback for you guys. Now, for some reason, video physics did not have sound, so I wanted to show you guys the video with sound before we go over to the app to analyze the data. So that was the video with sound, so now let's go over to video physics to watch the video with the dot diagram. So that was the video with the dot diagram. And since I was tracking myself as the object, I wanted to track the center of the mass, which I used the front of my hips to make sure I was getting the data points as accurate as possible. The dots are slightly hard to analyze in the dot diagram just because we are in 2 dimensions, so I'll wait until we go to the graph to further analyze the data. I am moving in 2 dimensions though, because you can see I'm jumping forward and up at the same time. If we were to go into the origin and scale, let's go here, you can see that I put my origin at my first data point, which is right before I took off, and my scale is the length of my tap board. And I know my tap board is 6 feet, which translates to 1.83 meters, so I put the scale as 889 pixels equals 1.83 meters. Now let's go to graphical analysis to further analyze the data. Let's start by analyzing the x component. Now for the position versus time graph, my line looks fairly linear, and if we do the curve fit, you can see that my line lines up fairly well with the line that it gives me. Now, since my line is fairly linear, we know that my velocity is constant, and we know this because the position versus time graph shows us the velocity. In this case, my velocity is 0.874 meters per second. And we also know that the velocity in this case is also positive because I'm moving in the positive direction. Now when we go to the bottom graph, since mine doesn't look that linear right now, I'm going to pinch zoom out. And it still doesn't look perfectly linear, but it looks a lot better than it did before. At my first data point, you can see that my velocity is 0.955 meters per second, and at my last data point, my velocity is 1.123 meters per second, which shows a change in velocity. Now, this is not what we would expect in a perfect world, because if our velocity is constant, we would expect our acceleration to be 0 meters per second each second. But in this case, it is not, due to air resistance I experienced while in the air, and air resistance slows things down. So if I got the slope of this graph in the most linear place I can find, which is over around here, you can see that my acceleration ends up being negative. Now this makes sense because I'm moving in the positive x direction, so my velocity is becoming less positive, and since my acceleration and velocity are moving in opposite directions, it makes sense that my acceleration would be negative due to the air resistance. Now we can analyze this in the y component as well, so let me change over to the y, not that y, that y. There we go. Get rid of that. Go over here, get rid of that. So in the top graph, in the position versus time graph, you can see that this is not a linear fit anymore, and this makes sense because we know that there should be an acceleration in the y component, so there's not really a need to analyze the top graph anymore. On the bottom graph though, you can see that my line is not completely linear, but the middle part is fairly linear, so I can get the slope of that. Do the curve fit, get here, go there, and then get over here. There we go. So since my velocity changes from the first data point to the last data point, we know that there definitely is an acceleration. So the acceleration of this graph is negative 10.125 meters per second each second, which is not far off from what the acceleration should be, which is negative 9.8 meters per second each second, but that's only happens when there's no air resistance. Since my acceleration is so close to the ideal acceleration that all objects have on Earth with no air resistance, we can conclude that this experiment was very accurate. So, with all that being said, that concludes my video. Thank you.